Hello students, here we have a graph having the vertices A, B, C, D, E, F and Z, and the weights are given here from of the various ages. Okay, so here what we have to do, find the length of shortest path between A to Z using Dijkstra algorithm. So solution for this, first the initial labeling is, what was the initial labeling? Obviously you know it, vertex V. What are the vertices? A, B, C, D, E, F and what? Z. Then lambda of V. You know lambda of A we have to take 0, other one we will take as infinity here. Right? And T. T are all vertices now at initial stage. Right? This is our initial labeling. Okay. Now, what is the minimum at initially? It is A. That lambda of A is what? 0. So iteration 1. So what does it? Lambda of A is equal to 0 is minimum. Lambda of A equal to 0 is minimum. T becomes T minus A. Right? So the vertices in T adjacent to AR. Vertices in T adjacent to AR what? B, C, D. B, C and D. Okay. Therefore, lambda of B is minimum of old lambda B and lambda of A plus weight of an age from A to B. So what it is? Minimum of, what is old lambda of B? It is infinity. Lambda of A is what? 0 plus weight from age from A to B is how much? 22. So it is what? 22. Then lambda of C is minimum of old lambda of C and lambda of A plus weight of an age from A to C. It is minimum of, what is lambda of C? Old, infinity. Again 0 plus age from A to C is a 16. So it is how much? 16. What about lambda of D? It will be minimum of old lambda of D, lambda of A plus weight of an age from A to D. So it is minimum of old lambda of D is again infinity from initial table. Here 0 plus weight of age between A to D is how much? 8. So it is 8. Therefore our new labeling will be vertex V, that is A, B, C, D, E, F and Z. Right? So now lambda of V, for A it is 0 as it is, for B it will now 22, for C it is 16, for D it will be 8 and these are as it is infinity. Right? So now what is in T? T is T minus A. So simply A is cancelled, B, C, D, E, F and Z are there. A will be eliminated. Right? So hence now look at this T and check the minimum of lambda in that. So minimum is what? 8. So hence minimum labeling is what? Lambda of D is equal to 8. So our iteration 2 iteration 2 will be for lambda of D is equal to 8 is minimum. Lambda of D is equal to 8 is minimum. Therefore, T becomes T minus AD. What is the adjacent? Adjacent in among these except A. Adjacent among these to D. What was the adjacent to D? Look at it. C, F. C and F only. So, the vertices in T adjacent to D are what? C and F. Okay. Therefore, lambda of C, it is minimum of old lambda of C, comma, lambda of D plus weight of an edge from C to D. Right? So it will be old lambda of C is how much? 16. What is lambda of D? 8. Weight from C to D or D to C is how much? 2. So what is the minimum here? 10. Right? Now lambda of F we have to find. So minimum of old lambda of F and lambda of D plus weight of an edge from C F to D. Right? So it will be what? Old lambda of F is how much? Infinity. Lambda of D is 8 plus weight from D to F will be what? 6. So it is 14. Therefore, our new labeling is vertex V, A, B, C, D, E, F and Z. Lambda of V. What is lambda of V? For A 0, for B it is same. It is not adjacent. So simply for D it is 8 as it is. For C it changes. So it will become 10. For F it will be 14. For E and Z it is remain same, infinity. Now what about T? Simply A and D we will eliminate. Otherwise B, C, E, F, Z are there. So what is now? Remember, to find shortest path we will write this series. Lambda of A is what? Lambda of A, then lambda of D we are getting. And now what is it? Minimum here. Among these remaining vertices, what is the minimum? Among 22, 10, infinity, 14, infinity. So 10 is minimum. So hence, minimum labeling is minimum label is lambda of C is equal to what? 10. So it will go to lambda of C now. Right? So let's find out the labeling new table for this lambda of C. Iteration 3, lambda of C equal to 10 is minimum. Therefore, T becomes T minus ACD. The vertices in T adjacent to among these B, C, E, F, Z. So between B, E, F, Z, what was the adjacent to C? Adjacent to C are, look at it, B is there, F is there and Z also. Are what? Are B, F, Z. All are they. B, E, F, Z. B, E, F and Z. Therefore, lambda of B. is minimum of old lambda of B, comma, lambda of C plus weight of an age from C to B. So it is minimum of whom? Old lambda of B is 22, lambda of C is 10, and weight of an age from C to B is how much? 20. So it is 22. Then lambda of E is what? Minimum of old lambda of E and lambda of C plus weight of age from C to E. So it is minimum of old lambda of E is how much? Infinity. Lambda of C is 10 plus weight of an age from C to E is what? 6. C to E it will be 4. So it is 40. Okay. Then lambda of whom? F. It will be minimum of old lambda of F and lambda of C plus weight of age from C to F. So it is minimum of old lambda of F is 14 and lambda of C is 10 plus weight of age from C to F is what? 3. So it is how much? 13. Okay. Then lambda of Z is minimum of old lambda of Z, lambda of C plus weight of age from C to Z. So minimum of old lambda of Z is infinity. What is lambda of C is 10 plus weight of age from C to Z is 10. So it is how much? 20. So our new labeling is vertex V, A, B, C, D, E, F, Z. Then lambda of V. Lambda of V 0. For B it is 22. For C it is 10 as it is, right? For D it is 8 as it is. For E it changes, it will become 14 now. For F it will be 13. For Z it will be 20. What is T? T becomes except A, C, D. So B, E, F, Z. What is the minimum among B, E, F, Z of lambda? 22, 14, 13, 20. So this 13 is minimum. So hence minimum label is lambda of F is what? 13. Therefore our next iteration for lambda of F is 13. So iteration 4 is that lambda of F equal to 13 is minimum. Okay, this gives T becomes T minus A, C, D, F. Okay, now the vertices in T adjacent to F, vertices in T adjacent to F are what? B and Z. Among these one are B and Z, right? Therefore lambda of B is minimum of old lambda of B, lambda of F plus age, weight of an age from F to B. So it is minimum of old lambda of B is how much? 22. Lambda of F is 13. Weight of an edge from F to B is what? 6. So this is what? 19. This minimum one is 19. Lambda of Z. Minimum of old lambda of Z. Lambda of F plus weight of edge from F to Z. So it is minimum of old lambda of Z is 20 and lambda of F is 13 plus weight from F to Z is 9. So this is what? Minimum is 20. So our new labeling is vertex V. That is what? Again A, B, C, D, E, F, Z. Then lambda of V. What is lambda of V? 0. Lambda of B changes 19. Lambda of Z it will be 20. Other one as it is. Right? Now what is T? T is this. T minus ACDF. ACDF. So VE Z. So what is the minimum among BEZ? So this lambda of E is minimum. Hence minimum label is lambda of E is how much? 14. So here lambda of C, then what? Lambda of F, and then lambda of E we are coming till, right? So now let's do the iteration for lambda of E is equal to 14. So iteration 5. Lambda of E equal to 14 is minimum. Therefore, T becomes T minus what? A, C, D, E and F now, right? So, therefore, the vertices in T in these B, E, Z. So, adjacent to E. From E, there is an edge up to B as well as to Z. So, both are adjacent, right? Adjacent to E are B and Z, right? Therefore, lambda of B. What is lambda of B? Lambda of B is minimum of old lambda of B, lambda of E plus weight of an edge from E to B. So it is minimum of old lambda of B is 19. Lambda of E is 14 plus what edge? Weight of an edge from E to B will be 2. So it is how much? 16. Then lambda of Z is what? Minimum of old lambda of Z. Then lambda of E plus weight of an edge from E to Z. So it is minimum of old lambda of Z is 20 and this is 14 plus how much? 4. So this is 18 now. So our new labeling is vertex V, A, B, C, D, E, F, Z. Lambda of V for A 0, for B it will change to 16, for C it is 10 as it is, for D it is 8 as it is, for E it will be 14 as it is, for F 13 as it is. For Z it will now 18. What is T? T becomes, except these, A, C, D, E, F. A, C, D, E, F. So simply B and Z are there. Okay. So what is the minimum among B and Z? So hence minimum label is what? Lambda of B is equal to what? 16. Lambda of B is 16. So from E we will go to lambda of B, right? Okay. So let's do the iteration for that. So here iteration 6. Lambda of B equal to 16 is minimum. Implies T becomes T minus A, B, C, D, E, F. Okay. Therefore, the vertices in T adjacent to B is, adjacent to B is simply Z. B to Z there is an edge, right? Therefore, lambda of Z will be minimum of old lambda of Z, lambda of B plus weight of edge from B to Z. So minimum of old lambda of Z is how much? 18. Lambda of B is 16 plus this weight is 2. This one is 2. So it is how much? 18. Okay. Therefore, your new labeling is vertex Z, A, B, C, D, E, F and Z. Right? Then lambda of V is what? 0, 16, 10, 8, 14, 13 and this is 18. Right? What is T? T is simply Z. So only one vertex Z is left now. So here iteration stops. Hence minimum label is lambda of Z is what? 18. So iteration stops. Thus shortest distance from A to Z is what? 18. And shortest path is A, D, C, F, E, B and then Z. Remember this one. Reiterations, according to iterations we will write A, D, C, F, E, B and Z. So let's draw the path now. Here that path is this, so let's draw it. A, here D, then C, then F will be here, right? Then E, F, then E, then B and Z. So simply these one, A, C, E, Z is that. A, C, E, Z. We won't consider this F here. Okay. Look at this. A to D, then D to C we can go. From C to F we can go, but from F to E we want to go. So C to E we can go. C to E and E to Z. So what is here? This is 8. This is 2. Look at this is A, D, C, E and Z. 2. What is here? 4 and this is again 4. So this is what, how much? 18, and this is the shortest path here. So now let me give one homework to you. Same type of question. Find the shortest path from A to Z in the graph. The graph is given as A, here B, C, D, here E, F and Z. So A to B, C, D, so here A, B, C, D, E, F and Z, and the weights are 2, 1, 4, 2, here 2, 2, here 4, 7, 5, 3, 1 and 3. So find shortest path in this one using Dijkstra's algorithm. Okay, thank you. Here the chapter 2 is finished. In next video we will see chapter 3, that is Euler and Hamilton path. Thank you.